Okay, so here we're going to cut this video. First off, I'm going to do standard form. So this takes us back to our graphing lines, graphing all the linear forms. Okay, so we're looking at the part 3 of that assignment, and we're going to be covering standard form in this one, right? So we'll do 5, 6, and 7, and number 8 will be a homework problem, right? So this is standard form. And we know that because, again, standard form looks like the x and y on the same side, and everything is integers. There's no decimals, no fractions. Okay, so this is what we got right here, right? So the first thing we want to do is learn how to graph it, right? Because that's part A. So we want to make sure that we graph this the right way. Now, I've tried to tell you guys a couple different ways to do this, okay? The first way that I showed you guys is just copy the problem, copy the equation, and then let's do algebra, right? We have to understand that if I want to graph this in slope-intercept form, right, then what I do is try to write it so that I have my mx plus b on the other side. So that means I want to move all these other things to the other side. I want to move the 5x to the other side, and then I want to get rid of that too. Okay, but to move the 5x to the other side, you guys should know that that means I have to subtract 5x from both sides. That leaves us with 2y on the left, and on the right now, instead of writing 10 minus 5x, I've taught you guys to write negative 5x plus 10. Again, the 10 is positive, right? So it's plus 10, and the 5 is negative, so, I mean, this is still the same thing. Okay, at this step, most of you guys are used to that because we've done it so many times. But if you were absent, that might be kind of new. Okay, then we divide both sides by 2. Okay, and that cancels out this 2 right here. So the reason why we divided by 2 is because we wanted to get the y by itself, right? The reason why we moved the 5y to the other side was all to get this situation where the y is by itself. Now I want to rewrite this as negative 5 over 2x, and then the other number that we add to it is plus 10 over 2. So notice that both of these values are over 2. Okay? So this is the way we want to do that. Now the last thing that I could do to kind of simplify this a little bit more is we would try to break down the fractions. This fraction is irreducible though, so it'll stay as negative 5 over 2. But this is not irreducible, okay? 10 divided by 2 is 5. So if I was going to go draw this graph now, I would go to 5, and then what I would do was go over 2, and then I'd go down 5 steps, right? Well, that's only 4 steps, right? So I go down 5 steps, right? Over 2 and down 5 steps, right? Over 2 and down 5. And when it goes off the line, that's good enough. And you guys can connect your points and see that that is the line that we want to graph, okay? That's this line right here. Now, the problem that we're asking you, there's more than one way to do this, but this is one way to solve the problem, all right? Another way to do this, another way to graph it, which I'll show you guys right now, is to look for the intercepts, okay? So one common thing that people will do is they'll think, well, what happens if I plug in x equals 0, right? What if x equals 0? Well, if x was 0, right, then that would mean that I've had 5 times 0 plus 2y equals 10. So we could think about it, right? If x equals 0, then y has to be equal to what? Right? What does y have to be equal? Well, in this case, y would have to be equal to 5 because it's the only number that I could do to get me 10, right? It's the only other value. If I do 2 times 5 right here, right, then this is true, and I have 10, right? So we understand that that's what's going on here, okay? So that means that the point x equals 0, y equals 5 is a point on my graph. X equals 0, y equals 5. But notice that that's that point right here, okay? Another way to graph this would then be to think, what if we change this around? What if instead of saying, what if x equals 0, what if we make the other one 0? Okay, so this will give us our x-intercept, right? What if y is equal to 0? Then x would be equal to what? Well, let's switch those around. So now if y is equal to 0, then that means I have a 0 in here. And 2 times 0 is 0. So what number can I plug in here so that I get 10? Well, that number is 2, right? So if y is 0, then x must be 2. Now think about that. That is the point. X equals 2, y equals 0, right? Again, the x-coordinate goes first, right? It's a point. And so look, that's this point right here, okay? So another way to do this would be to get your x and y intercepts by plugging in 0 and to go put those points down, okay? In the future, we'll work on that strategy a little more. But for this round, I was really focusing a little bit more on the algebra of moving around things and changing between forms. And I really wanted you guys to get really familiar with slope-intercept form because it's going to be the form that you use the most throughout all the math that you do. Okay, so now for C, we want to see whether or not 4, 7 is an equation. So for part C, we're going to just copy our equation. Okay, and I could also do this one the same way, right? In part C and D, we do them the same way. Okay, go ahead and just write it like that. Now what I will do is I'm going to put my values inside of here, right? So I'll go ahead and do x is 4 and y is 7, right? So in this case, we're going to do 5 times 4 plus 2 times 7, right? And we want to check, is it equal to 10? Okay? And you guys, I hope, have seen that we did this a lot of times, that no, this is 20 plus 14. Okay, that's not equal to 10. And so we know that we can make this statement, no. Okay, the point 4, 7 is not a solution to the equation. To this equation. Okay, so this will be a good moment for you to check this one on your own right now. Okay, we'll do it together. Don't forget to pause the video and see what you're going to learn. So if I do 5 times 0 plus 2 times 1, is that equal to 10? Okay, well, no, because on the left side we get 0 plus 2, and 0 plus 2 is not equal to 10. Okay, so we can go ahead and say no. Okay, no, in this case 0, 1 is not a solution. Alright, so this looks alright. So we could be done with 5. Okay, we've made both of our decisions, and that's the way it goes. So we'll try another example. We'll do 6. So here we are, number 6. Okay, again, which form is this that we're looking at? Well, we're looking at standard form. Okay, we got the x and y on the same side. There's no fractions, so we know that we have standard form. Okay, the next thing that we want to mention, though, is how to graph it. So how do we graph this? Well, we can do it the other way, right? Where you guys plug in the x and y's and go get those two values. That's one way to do it, okay? But again, dealing with the negatives and one little number might be wrong and you got to figure out what the other one is, okay? So we could try it that way right now, okay? Let's see. What if x was equal to 0? Then what would y have to be so that I get 20, okay? And you should see that y would have to be 4, right? Because this is 0 and 5 plus 4 is 20, so the only way that I get 20 equals 20 is if y is equal to 4. So what that tells me, this is a point, right? X equals 0 and y equals 4. This is a point on my graph. So that point has to be there. You got me? I could then reverse the process, and then instead, what if I give a 0 to the 4, to the y, right? What if this is a 0? Well, now what would I have to have so that I do -2 times it, and then I get positive 20? Well, you know a negative times a negative is a positive, so I'd have to have -10 in there, right? So again, this tells me, right, because that's going to make positive 20, right? A negative times a negative is a positive, and 5 times 0 is 0. So look, this is true. And that tells me that the point -10, 0, is then on the graph. But notice that this is off here. It's all the way over there. So if we want to complete this problem, we can see that's not the way to get it in this case, all right? To graph this equation now, what we're going to do is we'll turn it into the form that we need it to, okay? So the whole purpose of this video is to make sure that you guys get this little mechanical process of taking the 2x and bringing it to the other side, which means I have to do the opposite. So I'm going to have to add it to both sides so that we can eliminate it from the left, okay? We would say that these two things eliminate each other. They go away. And so now we just have 5y. And again, I've taught you guys to put the x before the constant, right, so that we get our mx plus b form. Now I want to divide both sides by 5. Okay, so we're getting close to the end here. I cancel out the 5s and I get y equals 2 over 5x plus 20 over 5. Well, what's that make though? Okay, 20 over 5, I think we know, is 4. So what we have right here is that I know that I could go up to 4, but look, we already have that point on our axis, right? And now to do my slope, I go over 5 and I'll go up 2. Okay, so I can continue that pattern in both cases. And then we can continue the line, and you can see, right, our x-intercept was going to be all the way over here. It's a little bit off the graph. So this graph is done, and now what you guys would do would be to get in here and start to test part C and D. So notice everything I did had nothing to do with C and D. Okay, those of you that have been following along with this assignment kind of know that I've been using this place to get that work done. And I think some of you guys know that you were supposed to do that work that I just did right here in this section. You guys were probably supposed to do that work down here, right? You guys would write your negative 2x plus 5y. Again, we did this in class and you guys knew where to do it, so do it there, work down. Okay, well in this case for C, I'm going to copy my formula and do it right here on the paper where it is. Okay, and I'll do this one in a different color. But again, notice I'm copying the same exact formula. Okay, now what we're going to do is we're going to go plug in our values. So I see that in this case, okay, and then we want to check to see is this equal, right? That's our whole point. So we use our x and y for part C. I'm going to use these two, and then for D, you're going to use those two. Okay? Well, I'm going to put in 4 right here and 7 right here. Okay? 4 times negative 2 makes negative 8. And then 5 times 7 makes 35. Okay? This is not going to be equal to 20. So we could go ahead and cross that out right away. We already know it's not equal to 20. So we can say no. Okay? 4, 7 is not a solution. Okay, now over here on D, what we're looking at is negative 2, okay, plus 5y, and then we're going to see if it's equal to 20. And the numbers that we'll plug in will be these two again. So x equals 0 and y equals 1. Okay, is this true? Is it true that 0, right, 0 times anything 0, is it true that 0 plus 5 equals 20? No, that's not true. So we will write no. 0, 1 is not a solution either. Okay, so that will be the idea. No, 0, 1 is not a solution. Okay, so number 7 will be the end of this video. I probably won't finish the whole problem, but I'll at least start off the part where you graph it, and I hope that you guys can do this part on your own. Okay, if you need more examples, I'm going to do the video after this that is the official practice test video. So this is just part of it. All right, so here we go. I believe this is number 7. So now what we're looking at is the form of this equation, and this form is standard form, right? Okay, we can look at part C right now. Let's get this out the way before we jump in too far. So we'll even learn something while we do it this way, okay? Because we'll be able to do the graph too by doing this, okay? Let's go plug in our 0, 3 and see if it's a solution to the equation. Don't forget that if it is, that means that the point is on a line, and so that means that we could go put it on the paper if you think about it, right? So is this true? Well, 3 times 0 is 0, and 0 plus, well, 3 times 5 is 15. Is it true that 0 plus 15 equals 15? Yes, this is true. And therefore, what we can say is yes, all right? 0, 3 is a solution, which means that 0, 3 is on the line. Okay, so that means we could go ahead and put that point. X equals 0, y equals 3. That point has to be there. Okay, let's go try D right now. Okay, so I'm going to use the same formula. Again, 3x plus 5y equals 15. And then what we do is we go drop these two numbers. That's my x and that's my y. So is it true that 3 times 5 plus 5 times 0 equals 15? Is that true? Well, yeah, because 3 times 5 is 15 and 5 plus 0 is 0. Sorry, 5 times 0 is 0. So 15 plus 0 is equal to 15? Yeah, that's true. Okay, so what sentence are we going to say? Yes, right, 5, 0 is a solution. Okay, I think you guys get my point here. I know I'm getting a little lazy here because we're at the end, but let's go drop this last point on there. Okay, this point is 5, 0. So that means I got to go right 5 and up 0. So look at the blue point and the red point. If I connect them, I will end up getting the graph that I need. And you can see, look, I'd have to go over 5 and down 3. Now, if I just do the math this way, you guys might be able to see what's going to happen, right? I'm going to move that 3x to the other side. So that means I'm subtracting 3x from both sides. Okay, and that gives me 5y equals negative 3x plus 15, because again, we want to write it in mx plus b form so that it looks better. Now, if I divide both sides by 5, look at what I see here. We cancel out those, and we get y equals, I split up this fraction into 2, we get plus 15 over 5. But what is 15 over 5? That is just 3. Right? So look, 3. What is this? This is our y-intercept, and look, it's right here at 3. And then it's telling me to go over 5 and down 3. But look, if I go over 5 and down 3, I'm getting those 2 points. So all I have to do is really connect these, and that's the idea, right? So it's going to be over 5, down 3. Right, so these are the points I'm going to connect, and that's my line. Okay, so I just showed you guys 2 ways to solve the same problem, and this is the end for standard form. Right? I know I've been owning you this video for a while. I did record it, and it got erased, so here it is. Right, it should be up. Again, look for the practice test video that's coming up next.